Hello guys, welcome back to the channel once again. In today's video, we are breaking down one of the most important protocols on the internet, HTTP and its secure version, HTTPS. This is part of our networking fundamentals playlist, so without wasting much time, let's dive right in. In the OSI model and also in the TCP/IP model videos, we have learned a lot about the application layer and one of the most prominent protocols which operate in that layer, which is the HTTP. HTTP is an abbreviation for the Hypertext Transfer Protocol and is the foundation of communication on the web. It is worth noting that the World Wide Web is not the internet actually. The World Wide Web is one of the services the internet provides. It is basically a collection of many websites which form a web, hence the name the World Wide Web. Now, whenever we visit a website, HTTP defines how your browser and the web server exchange information. HTTPS is simply the Hypertext Transfer Protocol with an extra layer of security. The S stands for secure, and it uses encryption through the transport layer security to make sure your communication is private and protected. The transport layer security is what makes it possible for users to browse the internet safely, from accessing financial services like online banking to logging into websites with our credentials. The transport layer security is what keeps all this sensitive data we share online secured. Before any encrypted data is exchanged, the client, which is your browser, and the server need to agree on how to communicate safely. This process is known as the TLS three-way handshake. This handshake is initiated by the client, which sends a client hello message to the server. This message will include crucial information like the TLS version the client supports, a list of ciphers it can use, which is basically a set of algorithm that will define the encryption and the key exchange process, and also a client random string. The server then responds with a server hello message, which will include information like the chosen TLS version and also a selected cipher suite from the client's list, a server random string, and most importantly, the server's digital certificate. This digital certificate contains the server's public key. In the third part of the handshake, the client generates one more random string which is called the pre-master secret. It encrypts this pre-master secret with the server's public key, which is from the certificate that the server sends, and sends it back to the server. Only the server can decrypt this pre-master secret because it requires the server's private key, which is kept secret on the server and never shared. At this point in time, both the client and the server are now in possession of three shared values: the client random, the server random, and the pre-master secret. These values come together to form the master secret. They each independently use these master secrets to generate the same set of session keys. These generated symmetric keys will now be used to encrypt and decrypt all the data for the rest of the session. Now both parties will send the finished message encrypted with the new session keys. This will indicate that a secure channel has now been established. HTTP is a request-response protocol that follows the client-server model. In simple terms, the client, most often a web browser, sends a request for a resource and the server responds by delivering that resource. 5 of the most important request methods used by HTTP is the GET, which retrieves data from a server. This can be a web page. The POST, which submits or creates a new data on the server, which is mostly used when we log into forms with our credentials. We also have the PUT method, which updates an existing resource by replacing it entirely on the server. There is also the delete, which simply deletes a specific resource from the server. And lastly, we have the patch, which partially updates an existing resource on the server. One main characteristic of HTTP is it being a stateless protocol. This simply means every request the client makes to the server treats that request independently. It does not automatically remember the client. Imagine logging into a website and then trying to visit your profile page. HTTP, being stateless by design, is not going to remember your login, and it is going to require you to log in again before you can visit the profile page. That is what we mean by it being stateless. Now, the solution to this is the use of cookies and sessions. Cookies are basically small text files that a web server stores in a user's browser, and they contain key value data like the session IDs or other user preferences. Before a cookie is formed, the client first sends a request to the server. The server then sets a set cookie header onto the response is going to set back to the client. The server establishes a session and includes a session ID into the set cookie header it sends back to the client. These cookies are stored on the web browser, and it automatically includes the cookies in the subsequent HTTP request it is going to send to that server. So with the help of the session ID the server attached in the cookies, it will now be able to recognize the client web browser. So, in short, sessions store the stateful data on the server, and the clients only hold the session ID, which is often within the cookie, which the client also stores on the browser. When the client sends this ID, the server retrieves the corresponding session data. That is how cookies and sessions work together to help users have a pleasant browsing experience on the web. From being able to store items in our online shopping carts to staying logged in whilst we browse in our favorite websites, HTTPS, with the help of TLS, encrypts this whole process of cookies and session creations, thereby making our whole online browsing experience a very secure one. Now, sometimes when a user interacts with a website, the browser may need to fetch extra data from other servers. For example, pulling weather information, payment services, or maps. These requests are made through web APIs, which are application programming interface. In this process, the browser sends an encrypted HTTPS request to the API endpoint. The API server processes the request and sends back an HTTPS response, usually in JSON or XML format. So, in conclusion, we've seen how HTTP is a protocol that powers communication between browsers and servers. HTTPS adds encryption through TLS to keep that communication secure. How HTTPS helps us to securely access additional resources on the web through APIs. And also how cookies and sessions help bring statefulness to HTTP. If this video helped you to understand the HTTP and HTTPS protocols, don't forget to like the video, share it with friends and colleagues, and also subscribe to the channel for more videos on the Networking Fundamentals playlist. Until next time, goodbye and thanks for watching.